Have you ever wanted to build a 3D printing, IR blasting, gray code, IoT, disk spinning wind direction sensor? Well, today's your lucky day because I spent way too much time building exactly that. But first, some backstory. Me and my class got assigned to do a IoT project. Naturally, almost the entire class started building Lego catapults and tanks. There was even a fully functional railgun, so I felt a responsibility of sorts to not build a weapon, and therefore I decided I would build a weather station. I drew up an impressive amount of requirements and then a quick sketch. I had some pretty cool sketches of the wind speed sensor, but I decided I would start with the wind direction. I could have just put a potentiometer at the bottom of it and call it a day, but I decided to make it a bit more hard for myself. This is a really bad sketch, but I'll try to explain it the best I can. So we have the wind vane on top, connected by a shaft or something, down to a disc. So when the wind vane spins, the disc spins too. This is then supported by two bearings and an enclosure. The disc would look something like this, like a messed up pie or something, where some parts of it would let through light and some won't. We can now see that each pie piece has a unique combination of light and no light. We can then assign each pie piece to a wind direction. For example, no light, no light, no light is north in this case. Now let's look at this from the side again. We have some transmitter diodes at the top and some receiver diodes at the bottom. The light then shines down, and some of it gets through and some of it gets blocked. We can then read this as a binary number and interpret this as a wind direction. I connected two IR LEDs as well as two IR receiver diodes to the Arduino, then wrote some quick code and just wrote out the analog values into the console. In doing this, I could verify that I could both transmit and receive IR light. I then made this small-scale cardboard prototype using 2 instead of 3 pairs of IR diodes. This would only give it 4 different wind directions instead of 8, but this was just a prototype. Back in school the next day, I wrote some quick code. Then I turned the arrow, slowly turning the disk inside. Would you look at that? The computer actually displays the correct heading. Now we need to do something about the cardboard situation. Before we get into CAD and the full-size version, I need to explain the difference between binary and gray code, which is just an altered version of binary. Let's say we want to move from decimal 3 to decimal 4 using binary code. Well, from 011 to 100, we can see that every bit changes, which in itself is not a problem, but let's say that one bit would change a bit faster than the others. Well, for a brief moment in time, we will get another binary code. For example, 111, which is decimal 7, or maybe 001, which is decimal 1, or 010, which is decimal 2. With binary code, we can end up really anywhere if the machine reads the code a bit off. Sometimes it changes 3 bits, sometimes it changes only 1 bit, and sometimes it changes 2 bits. That's just how binary code is. Now let's look at the gray code. So from decimal 0 to 1, we can see that 1 bit changes. From 1 to 2, 1 bit also changes. From 2 to 3, 1 bit changes. Hold up, I'm seeing a pattern here, it's just 1. Now let's look at our previous example, but this time using gray code. So from 010 to 110, only 1 bit changes. So even if it reads it a bit off, we still end up somewhere around here, instead of, well, all over the place as with normal binary code. I changed the disk from binary to gray code, spaced everything to my liking, and started designing the enclosure around everything. This was the first time I used constraints in my CAD software, and well, it was a bit weird, but in the end I got something I was pretty happy with. At this point, our teacher realized that nobody had even as much as looked at an ESP32 in his IoT project. So everybody had to do this ESP32 Blink website tutorial, which went pretty well for us. Then, tragedy. I had always assumed that the bearings I was going to use were 4mm tall, but in reality they were 8, and now nothing fit my CAD models. Also, my favorite constraints absolutely, it was quite a mess, but after some work I got the CAD back to normal. I printed out my parts and got ready for assembly. All I had to do was just move that piece of spaghetti over there to my new parts while adding another pair of IR diodes. I did a quick test fit just to see that I got signal on all 3 inputs, and then I started putting everything together. Here we can see the disk spinning inside of the enclosure, and here is another view where the top cover is on, and we can really see how it opens and closes the holes for the diodes. I glued on the diodes, got a lot of wires and resistors, and made some even worse squares by than before. Now, the moment of truth, would it work? Well, turns out it actually did, this time with an even better accuracy of 8 different wind directions instead of 4. And well, it was not cardboard this time. At this point I decided it would be time to finally move over the code from the Arduino to the ESP32 to do all of the IoT stuff. I checked that the encoder as well as my Arduino still worked from the previous lesson, which it did to my relief. I found an ESP32, connected it to my computer and loaded the code. At first everything seemed to run pretty okay, but soon I noticed something was a bit off. You see, the wind direction only changed between north and northeast. And as I looked a bit closer on it, it seemed like it was actually only the first bit in the gray code that was actually changing. The other two were just constantly 0. I moved everything over to the Arduino again and everything worked there, so I concluded that the problem must have been with the ESP32. I went back to the ESP32 again, and this time the A0 and A1 channel were spiked at 500 and 300 in analog values, but nothing was connected to the ESP32. But when I actually did connect something, they turned into 0. Thinking it could have been something with the code, I wrote a completely new program used to try to read one analog value, but this didn't work either, so I don't know, I'd spent way too much time on this and the deadline was steadily approaching, so I had to move on. It's finally time to design the wind vane. At first I just stole an image off of Google and tried to trace it, but this looked really stupid, so I decided I would do something based off of a rod or something. It could be a barbecue skewer. So I made this mount that would fit around my pen, and then I also tried to do a nose cone, which it just wouldn't work, so I made a couple of work planes and made this loft feature to make it rounded. I also made it thin. And here we have the final wind vane. I actually think it looks pretty cool. While the parts were being printed, I decided I would cut down the length of my pen a bit, so I found this really appropriate bolt cutter, and it was not the right tool for the job. I just kind of destroyed my pen, but the print was finally done and I started assembling it. Here we have the final wind vane. I actually think it looks pretty cool. I could finally put everything together and there we have it. Since this is my addition to No Effort November and it's 1 week left till 2025, I don't have a better ending for this video. Actually, that is my only and very last image of my creation, since my teacher stole it to show other students, and it's been almost a year at this point and I haven't seen it since. Also, remember my requirements in the beginning? Well, I only fulfilled one of those, so yeah. Anyways, Merry Christmas, Happy New Year, and I'll see you in the next one.